Kirkman. All right, ladies and gentlemen, this is our 7.1 part 2 notes from class. This is where we're learning to solve those equations with variables on both sides, but from a word problem, okay? So we are going to show you what that looks like. If you have your note takers, you can fill this in with us, or you can just follow along and take some notes and do some practice problems. In the beginning, we're going to just make sure we understand the difference between an expression and an equation. So expressions do not have equal signs. And you can see here in examples, they have terms that are separated by operation signs like addition, subtractions, multiplication, division signs. And they have letters and numbers. These are expressions. They express something. They cannot be solved. They can only be simplified. Then on the other side here, we have equations. Equations do have equal signs. And because they have equal signs, that means that they can be solved. We can get an answer for these. So you have here, you can see the equal signs right here. You can also look that on both of these examples, the expression here is the same that's in this equation. So equations are made up of expressions, two expressions usually, that are set equal to each other. All right, so we're going to jump in right away and we're going to do this word problem here. So Andy's rental car charges an initial fee of $20 plus an additional $30 per day to rent a car. Buddy's rental car charges an initial fee of $36 plus an additional $28 per day. For what number of days is the total cost charged by the companies the same? So I know that there are two companies. We've got Andy and Buddy. And we want to know when the two's price will be the same. So I'm going to end up setting them equal to each other. Now here we have some generic steps, but really these are the same steps you would do for any word problem that's in this, this same type. You're going to write an expression for one side of the equation, write an expression for the other side, and then put them equal to each other to make your final equation. And then the final thing is then just to solve for x like we've been doing. If I look in my things, Andy's rental car has an initial fee of $20 plus an additional $30 per day. This verbiage, the wording should sound pretty familiar to you. When we were in the beginning of the first semester, when we were writing equations to fit our slope-intercept form, we had the same words. We had an initial fee or an initial value. And then we had a price per or something being multiplied. So what we're basically going to do is take two of these slope intercepts and we're going to set them equal to each other. And that's going to be our final equation. So if I come over here, our initial fee was $20 plus an additional $30 per day. So I'm going to have $30 per day plus the $20. That's going to be Andy's rental car. For Buddy's rental car, their initial fee is $36 plus an additional $28. So I'm going to have 28x plus the 36. So this expression represents the price for Andy's rental car, and this expression represents the price for Buddy's. What we're now going to do is set them equal to each other so that we can have an equation. So I'm going to do 30x plus 20 equals 28x plus 36. I'm going to solve this problem. So I'm drawing my mirror or my equal sign because whatever I do to this side, I need to do the same to the other side. And we're first going to get rid of our x's and try to keep them positive. That's why I'm going to get rid of the 28 because 30 take away 28 is a positive answer. Okay? See how I write out my steps though? I really want you to keep practicing writing out your steps because it's going to help you in future problems. 30 take away, whoops, that's not right. Hold on. Boop. 30 take away 28 is 2x. I'm going to bring down my 20. 28 take away 28 is 0, and that means the only thing on this right-hand side is 36. Now I can move my constants, my numbers, to the other side, because I want to get x all alone over here, or the x terms, and on the right-hand side I only want numbers, so that's going to be 16. Now I'm running out of room a little bit, so I'm going to kind of move it over here. 2x equals 16. I'm going to go ahead and divide by 2 to get x alone, do the opposite of multiplication, and I'm going to get 8. Now, because it's a word problem, I cannot just say my answer is 8. It wants to know how many days they will be the same. So my answer would be 8 days. If I rent a car for 8 days, I can pay, both companies would charge the same price, so it doesn't really matter which one I use. All right, here we have another word problem and the same type of thing. I've got a water tank 1. I've got a second water tank, and they're holding different water, but they're also leaking at different rates. And we want to know after how many weeks will it be the same? Will the amount of water in these tanks be the same? So I'm going to write an expression for the first water tank. I'm going to write an expression for the second water tank, and then I'm going to set them equal and write an equation with both. So the first water tank initially holds 256 gallons. That's my initial value, what I started with, but it's leaking, which means that it's going to go down and subtract gallons of water, and it's going down by 3 gallons every week. So that is my first expression. My second expression, my other water tank has 384 gallons to start, but it's leaking at 5 gallons a week. And I want to know when they'll be the same. So I'm going to set up my 256 minus 3x, and I want to know when is that going to be the same as 384 minus 5x. There we go. And now we solve. Again, I want to try to keep my variables positive. So if I add 5x to both sides, remember this is part of your term. Your term includes the sign in front. So even though it's a minus 3x, that's the same thing as if I rewrote my problem as plus negative 3x. Those mean the same thing. So this sign right here is included in my term. So to get rid of it or to add 5x to that, I'm adding it to a negative 3. Okay? So I'm going to draw my line. That cancels out. Here I've got 256 plus 2x, because negative 3 plus 5 makes 2. And then on this side, I'm going to have the 384 left. I'm going to subtract the 256 from both sides. And I'm going to be left with 2x equals, I'm going to borrow 128. So again, I'm going to rewrite it over here. 2x equals 128. Divide both sides by 2 to get x alone. And I'm going to get 64. So again, I'm a word problem, so that means it's going to take 64 weeks, okay, for both tanks to have the same amount of water in them. All right, so now this last problem is a little bit tricky. It's really just asking you, it's going the other direction. So we've been given word problems and had to write the equation for them, but can you go the other way? Can you be given an equation and then write the word problem that goes with it? And you can write almost anything as long as it makes sense in the real world situation. Think about problems that we've done recently. So we've done like companies that clean, companies that take care of dogs, companies that clean carpets, companies that are handyman. So I would probably stick with something like that. because the left side of the situation is a constant plus a variable, I know that I'm going to have some number, an initial fee or charge, okay? And I'm going to add that to some sort of rate, something I'm multiplying consistently. Because my right side is just a variable term, it's just going to include a rate. So that's where when you think of like a handyman, or in our last problem, we had the car rental company, or what was the one we just did? Hold on. What was this guy? Oh, the water tanks, right? We need something that has like an initial fee or an initial starting amount, and then we're adding on some sort of rate versus something else that's just a rate, okay? So you could almost think of like, animals wouldn't be good because animals have to have an initial poundage, so I can't compare it to this different rate. But the one that they give in the example down here is that a handyman charges $150 plus $25 per hour for house painting. A painter charges $55 per hour. How many hours would a job have to take for the handyman's fee and the painter's fee to be the same, for them to be equal? So I'm thinking we did some things with maids before. So maybe you could say you had a maid service, you had Molly's Maids, and they charged $150 for initially and then $25 per hour. And then you had Polly Perfect over here, and they charged just $55 an hour. There was no initial fee. How many hours would I have to have these people clean my house for them to be the same? So it's the same type of idea. So you can get creative with it if you want. But that's all I have for how to write an equation from a word problem and then solve using variables on both sides. Feel free to try some problems and reach out to me if you need help.